Capstone 6 is on geoengineering strategies. In order for us to keep global warming to manageable levels, meaning keeping warming below 3.6 degrees Fahrenheit or 2 degrees Celsius relative to pre-industrial times, it is necessary for various climate change mitigation and adaptation strategies to be implemented. The world was on the right track policy-wise for this to happen until the summer of 2017 when the United States unfortunately pulled out of the Paris Climate Accord. This is significant because the United States is one of the most significant contributors of CO2 to the atmosphere, and the U.S. pulling out of the agreement sets a bad precedent to the rest of the world. Potential mitigation efforts, including the increased use of renewable energy and the conservation of energy, are said to have more long-term benefits than short-term benefits. This is because the Earth's atmosphere is a very complex system, and these changes do not happen overnight. Although the short-term benefits to mitigation efforts are minimal, these efforts are necessary to achieve reduced global warming. Increased use of renewable energies such as wind and solar, along with energy conservation strategies, are an important component to how we should be approaching climate change. But other efforts may need to be made in order to keep warming below 2 degrees Celsius in the short term. Geoengineering strategies such as the direct removal of carbon dioxide and the injection of sulfate aerosols into the stratosphere can have more immediate effects on warming trends than traditional mitigation strategies. The idea of sulfate aerosol injection is based off of the effect of volcanic eruptions on the atmosphere. Basically, the idea is to add sulfate aerosols to the atmosphere in order to increase the Earth's albedo, and thus lower the amount of insolation that reaches the surface. This method has many drawbacks, however, including unknown effects on precipitation patterns and the need to constantly add to it in order to maintain desired levels of warming, which would have a large economic cost. Perhaps a better geoengineering solution would be the direct removal of carbon, especially the direct removal of carbon at the source, such as a power plant. The idea is to capture the emissions at the source and process and remove the CO2 before it can be added to the atmosphere. The extracted CO2 is then pumped underground where it is mixed with water and reacts with the basaltic bedrock, forming new minerals and converting the CO2 into rock. This process is sometimes called negative emissions and would have a large economic cost. This strategy may also have negative unintended consequences, including disturbing natural systems and land use changes. In conclusion, the best course of action appears to be for the global community to come together and adopt serious mitigation strategies. In order for warming to be kept to acceptable levels, we need to start globally doing a better job at conserving energy and using renewable energy sources. Until such policies are implemented and start to take effect, it may be necessary to start thinking about geoengineering strategies as a short-term solution to keep global warming below the 2 degrees Celsius threshold.